Hey guys, welcome to Ergo Forces. So today we'll be moving ahead with Leetcode problem 2271, that is maximum white tiles covered by a carpet. So basically I'll explain you the problem first, sorry. So it says that you are given a 2D integer array tiles where tiles I equals to Li to Ri. So basically we are given a range and it is saying that each tile in the range Li to Ri is colored white. So just assume you are given a plane and inside that plane there are several tiles, and then you are given a range such that every tile between that range is white. And you are also given a carpet of carpet length, and you have to find maximum number of white tiles that can be covered by the carpet. Okay, so I'll just explain this example. So here, what will the brute force approach for this solution? So, so I'll place the carpet at every tile and find out the number of white tiles that is covered under that particular carpet under that particular position. So let's say I'm having the carpet at index 1. So I'll loop through all the ranges and see which range comes under that particular carpet range. That is, if I'm at index 1 to 10, that is because carpet length is 10. So I'll start from in tile 0, and I loop through the whole array and check which all ranges come between this 1 to 10. Okay, so but that will be the order of n squared time complexity, and that will give you time limit exceeded error. Okay, so we need to find some optimized approach for this one. Okay. Okay. So let's say I am keeping the carpet at index 0 and tile 1. So I can go till 10, and we got the number of tiles as 6. Now again I am going from 2 to 11, and again we are getting 6. Similarly, if you get from 3, 4, or 5, if you keep the carpet at 3, 4, or 5, you will get 6 only. And why is it like that? Because the gap between 5 to 10 will be the same whether you keep the carpet at 1, 2, 3, 4, or 5, right? So, one thing which we got it from here, that we'll keep the carpet only at the starting index, only at the starting position of that particular tile, of that particular range instead. Okay, so I'll keep the carpet at 1, 10, 12, 20, and 30. Okay. Okay. Okay, now what other thing? Let's say if I'm keeping the carpet at 10, so I will go from 10 to 19, right? Okay, so now again we have to check that which all ranges lie between this particular 10 to 19 and all, and we have to will end up into n square again. So okay, so can we do something that one thing is for sure, that we have to get a solution which is less than n square. Okay, so we do not need to traverse array more than once. So can we do something like, if I take this whole range, okay, then I will get the number of tiles between 1 to 19, or let's say 1 to 20. Okay, so can I just subtract from 0 to 9 whatever tiles are getting we are getting? So can I subtract that from 1 to 20? Yes, right, we can do it that way. So you might have got till now that we will be using prefix sum here. So at each index we will will take the number of tiles till that particular index, and for finding the number of tiles between a range, we will just subtract the number of tiles which we got before that particular, let's say before 10. So okay, so basically what we'll be doing is, let's say I am taking I'm taking, okay, first of all, let me build up the prefix sum. So here it is 5, then from 10 to 11, so it becomes 7, then 12 to 18, so 7 plus 7, 14. Okay. Then comes 20 to 25. So that this is 6, and again it becomes 20, and 30 to 32, so it becomes 23. Okay, so now I want to find out from 10 to from 10 to 19. Okay, so for finding from 10 to 19, okay, so here as you can see, the 19 is not there in any of the ranges, right? But can we do something is, that we find out the closest range which is there from 19? Yes, we can do it, right? But here we cannot take 10 and 11 because otherwise we'll lose all the ties between 12 and 18. And similarly, we cannot take 20 and 25 as well, because then in that case it will it goes out of it goes it is because it goes out of the range, that is 10 to 19. So basically in this case 12 to 18 is the lower bound. So for finding from 10 to 19, so we'll do 14. 14 is the number of tiles which we got from 1 to 18, minus minus we have to ignore the 19th one because there is nothing in that at that place. Minus, we'll just subtract all the tiles before 10. That is 0 to that is 1 to 9. We have to subtract. So I'm at index 1. So I'll just subtract the tiles at index 0, and that will end up being 9, right? And you can cross check in the example that this is the correct answer, that is 10 to 11 and 12 to 18, that ends up into 19, right? That ends up into 9. Okay, so this is one of the case, and now let's go ahead and let's try 12 to 21. Okay, so I'll just take from 12 to 21. Okay, so here if I found the lower bound of 21, then it is at index 3, right? It is an index 3, but as you can see, the 21 already lies in this range. So what we'll have to do in this case is, so I can see that here till 25, the total number of tiles are white tiles are 20, minus, of course we will remove all the tiles before 12, that is that is before the index 2, so that is 7. Hmm. And here we are considering the tiles till from 12 to 25, so we have to remove tiles from 22 to 25 as well, right? So minus 25 minus 20 21, that is 4. Okay, so it is 4 because 22, 23, 24, and 25. So that ends up into 9. And again, this is the right answer. You can cross check yourself. So this is how we'll approach this solution. And for finding out lower bound, we will use binary search. So what would be the time complexity in this case? So it is log n for doing binary search. Okay, and log n, and along with that we have to remember that we are the traversing the array also, so it will be n log n, and the space complexity will be order of n, as we are using prefix sum. So this is all about this, and now let's move ahead to the coding part. Okay, so what all do we need here? We will need a prefix sum. And before that, we have to sort the array, right? Because you might be given the array in this form also. So first of all, I'll sort this array, tiles and A, B, and we will just compare integer dot compare A of 0 and B of 0. Okay, so this will sort the array. Now, then do we need is we'll need a prefix and presum equals to new integer, then tiles dot length. Okay, now I'll just loop through the tiles. Integer I equals to 0, I less than tiles dot length, and then I plus plus. So presum at I equal to presum at I plus I minus 1 plus tiles of I 1 minus tiles of I and 0. Okay, so there is one more thing which we have to keep in mind, that here if I start from 0, so my pre-sum, this will give me index out of bound error. So we will start from 1, and pre-sum of 0 will be 0. So basically if I am considering the 0th index of the tiles, so it will be, I'll be able to get the pre-sum at index 1. Okay, so here this is fine, and tiles should be minus 1 minus 1. So basically we are calculating if I equals to 1. So pre-sum of 1 equals to pre-sum of 0 plus tiles of I minus 1 minus tiles of I minus 1 0. Okay. So this we have got the pre-sum. Okay, now I'll just loop through the tiles again. I plus plus. Now I'll start from um, I'll start from tiles of 0, and I'll go till tiles of 0 plus carpet length minus 1. Okay, because if I am starting from 1, then 1 plus 10 is 11, but I have to go only till 10. Okay, because this is including 1 and 10. Okay, so now I have to find lower index equals to lower index of lower index of tiles and upper. Okay, so this we got the index. Now tile count equals to pre-sum at lower index, okay, minus pre-sum at I. Okay, because I have considered I here, because let's say I have started from 10, so we have to, I am at I1, so we have to subtract the pre-sum at I minus 1, that is pre-sum at 0. Okay, so and again there is one more case left. So let's say I am selecting the lower bound of 21. Let's say I'm starting from 12 to 21. So 21 is between the 22 and 25, that is 21 is present in the range of lower index, range in the lower index, right? So I'll have to subtract the upper bound of this lower index, that is tiles of lower index 1 minus tiles minus upper because I have to subtract 25 minus 23. Okay, so this is the tile count, and finally I also have to have one variable, and I'll have to take the maximum equals to math.max of max and tile count. Okay, and I'll return max. And not to forget, for completing the method lower index, so this will return me the index. I'll have the tiles array inside this as well, and I'll have num, for which we have to find the lower index. I'll have two variables, lower equals to 0 and upper equals to tiles.length minus 1. I'll have one more, mid equals to 0, and one more, that is lower index equals to 0. Okay, now I'll loop till lower less than upper. So this is basically, I'm writing here binary search method. So if you are not aware of binary search, then I suggest you to go through the binary search once. Okay, Now mid equals to lower plus upper by 2. Now if, now comes the thing. So let's say I'm searching for 23. So if when here if I'm at index, if mid is at index 2, that is here, so I can see that 20 is less than 23 and 25 is greater than 23. That is 23 lies in the range 20 to 25. So I'll directly return mid. So how I'll search, I'll write the logic is if tiles at mid 0, it should be less than or equal to num, and tiles of mid 1 should be greater than equal to num. If this is satisfied, then I'll directly return mid. Else if my mid is at, let's say 8, at index 1, and I have to search for 19, so 18 is less than 19, so in that case my most probable lower index will be this one. Okay, so I'll just write down mid of 1 if it is less than num. In that case, less than or equal to num, in that case I will do, first of all I'll store the value in lower index equals to mid, and I'll do lower index equals to mid minus 1. Okay, because I have to find the value with, I have to find the lower index such that it is as close as, it is as close as possible to the particular number. So instead I'll do lower equals to mid plus 1, and this is because let's say my let's say the mid is at index 0, and I have to still find the lower bound at 19. So we can say that at current point the lower index is 0, but I have to search if there is any other lower index which is more close to the particular number, that is 19. So in that case I have to search in this range also, right? I cannot just directly return 0, because that might happen that there is some index which is more closer. So that's why I have done lower equals to mid plus 1. Else if tiles at mid and 1, if it is greater than num, then in that case I'll directly do per equals to mid minus 1, and then finally I'll return lower index. Okay, so this is it for the lower index method. I'll just rename it to lower bound for the readability purpose, and here also lower bound. Okay, so it's okay, I equals to 0, and tiles of here, see if I'm starting at 0, so this is fine, but for pre-sum I have to do lower index plus 1, because for range 0 my pre-sum will be at range 1, right? And here again it is, this is fine, because if I'm calculating at range 1, that is if I'm doing from 10 to 19, then I have to remove the pre-sum at I minus 1. Okay, so other things are fine, and okay, this I have missed out, tiles at I and 0. Okay, uh, and here I have to start from 1, because otherwise it will give me index out of bound error. Okay, and at I equals to 0 the prism is 0 itself. Okay, let's see if we are missing out something else. Okay, yeah, this should be tiles of I, and here also it should be I, and yeah, this pre-sum, we have to take till tile start length plus 1, because this pre-sum we are adding an extra at pre-sum 0, so it will be 0, so as to fix this index out of bounds error. And okay, other things seems fine, and this should also go till presum dot length. Okay, and coming back to here and tiles dot, yeah, this will give me negative value. So because let's say consider if you are taking lower bound for 19, right? So it will come here at index 1, and you have to do 18 minus 19, which might give you negative values. So you have to consider math dot max of 0 till tiles of lower bound 1 minus upper. So if if my 19 is out of the range of 10 to 18, then I'll just subtract nothing. Okay. Okay, now let's try to run the solution. Mm, okay. Oh, there is one more bracket, I guess. Out of bound error. This should be yes. See, here it should be I minus 1. Similarly, it should be I minus 1 here as well, because I am like as I mentioned before, we are taking we are for I for uh, tiles of 0, we are considering it at presum of 1. Okay. Okay, and one more thing we are missing here is, let's say if I'm considering from 10 to 18, so 18 minus 10 will be 8, right? But here we are not considering 10, so I have to add 1 here. Okay, now let's try to run it. Okay, so it worked. Now I will submit it. Okay, it got submitted. Okay, so if you have any doubts in this one, then then just do comment in the comment section. And I hope you liked this video. So please do like and subscribe. And okay, then bye bye.